So this is lesson 1.5 answer key. Starting off with naming angles or pairs, angle pairs that satisfy each condition. So you see that I made the drawing. Question 8 asks for two adjacent angles. Remember, adjacent angles have a common side. So I said angle HGE and angle DGE. You could have said angle CFB and angle BFD. You could have said angle JAD and angle DAB. There are several adjacent angles. Number 9, you're looking for two acute vertical angles. Remember, vertical angles are formed by two lines intersecting and the non-adjacent angles. So I said angle CGB and angle I have my point labeled wrong. I said angle CFB and angle DFE. Those are acute vertical angles. Number 10, two obtuse vertical angles. Sticking with that same pair of intersecting lines, I said angle BFD and angle CFE. But I also wrote, I'm going to write that in here, angle BFD and angle CFE. But also angle HGE and angle FGD. Number 11, two complementary adjacent angles. So complementary means they add up to 90. Adjacent, so angle EDG and angle GDF. Number 12, two complementary non-adjacent. That would be angle CBF and angle DAB. Number 13, two supplementary adjacent. That's any linear pair. So you could say angle CBF and angle FBA. You could also call that angle FBJ. But you could also say angle CFB and angle BFD, or angle EDF and angle FDA. So you're looking for any linear pair because linear pairs are supplementary. Number 14, a linear pair whose vertex is F. So that leaves you with angle CFB and angle BFD. You could have also said angle CFG and angle GFD. Number 15, an angle complementary to angle FDG. That would be angle EDG. An angle, for number 16, an angle supplementary to angle CBF. Supplementary to angle CBF is angle FBA or angle FBJ. And number 17, an angle that is supplementary to angle JAE. That would be angle EAB. All right. And the answers that I said are different than what I have written down because there's more than one. And so I'm looking at the picture answering those questions, not even looking at my own answers. So your answers may be different than what I have written, and they may be a little bit different than what I said. Most of those are sample. There are multiple answers. All right, you had to do numbers 20 through 26. I think it's a good idea to always draw the picture. I think that helps you, so that way if you're making a mistake, you can look back at your picture and see what's going on. So for number 20, I just said that 2x plus 4x plus 108 has to equal 108 because that's a linear, has to equal 180 because it's a linear pair. I find out that x equals 12. Number 22, I solved a unique way. I used a linear systems. So I said that 2y plus 6 plus 3x equals 180 because that forms a linear pair, but also 3x plus 8y minus 102 equals 180. The reason I did that was because I wanted to use substitution or elimination, solving a linear pair, to remind you guys what that looks like. So I put the equations in standard form, and then I eliminated my x values by subtracting, and then I solved for the y value, and then I plugged that back in to solve for x. Now I do see that there is a pair of vertical angles there, so I could have said that 2y plus 6 equals 8y minus 102. However, I did want you guys to see what it was like to solve a linear pair, because you're going to have to do that. You're going to have to start solving linear systems. So if you forgot how to do that, I would rack your algebra brain. Remember, you solved a system by using either substitution or elimination. All right, number 24. I used the vertical angles 114 degrees equals 5x plus 4. I found out that x equals 22. And then I plugged that value of x equaling 22 in and discovered, I just added up the whole sum of three angles to equal 180. So 114 plus 2y plus 3x minus 24 equals 180. 3x minus 24. 2y plus 66 plus 90 equals 180. You find out that y equals 12. Number 26 is a word problem. The measure of an angle supplement is 76 less than the measure of the angle. So I said I let x equal one angle and x minus 76 equal the other. I know that they're supplements, so the sum of those have to equal 180. I found out that x equals 128, so the other angle is 52. Now, my picture is not drawn to scale, obviously, because this angle clearly does not look like it's 128 degrees, and this does not look like it's 52. But I just draw a picture to help my brain process. Your picture doesn't have to be drawn to scale. You just need to kind of understand what the question is asking, okay? Number 29, 30, and 31. Number 29, 30, and 30, number 29 and 30 go off that picture I have to the right. So it says that the measure of angle KNL equals 6x minus 4, and the measure of angle LNM equals 4x plus 24. You need to find the value of x so that angle KNM is right. That means that the measure of angle KNM has to equal 90. So I summed those two values up to 90, and I find out that x equals 7. Number 30, you're proving that they are supplements. So I'm going to take the sum of angle JNP and the sum of angle JNL and set them equal to 180. And I find out that x equals 17. Number 31, I don't know what that is. Number 34, sorry. Number 34 was a word problem. It said rays AB and BC are perpendicular. So I drew ray AB, and then I drew ray BC, and I put a little right angle at the corner where they meet. I drew point D because it lies in the interior of angle ABC, and then I connected ray BD. If the measure of angle ABD, 3r plus 5, and the measure of angle DBC is 5r minus 27, well, they have to equal 90 because they're perpendicular. Perpendicular lines make four right angles, so I know that angle ABC is a right angle. So I found out that R equals 14, which means that the measure of angle ABD is 47, and the measure of angle DBC is 43. All right, next one, number 36. So you're looking at the picture I have drawn there, and you have to determine whether you can assume these statements based off of the figure. So are angles 4 and 7 vertical angles? Yes, they are. They are formed by two non-adjacent angles formed by two intersecting lines. So yes, you can assume that from the picture. Number 37, can you assume that angle 4 and 8 are supplementary? Yes, you can assume that they're supplementary because they're part of a linear pair and they're adjacent to each other. Number 39, can you assume that angles 3 and 6 are congruent? No, you cannot. It doesn't say anything about this line. It's really a line, it's got arrows on it, but it doesn't say that this is an angle bisector. You don't know any information about this or about this angle or this angle. It may look like they're congruent, but you don't know that for sure, so you cannot say that. Cannot assume congruency. Number 41, angle 5 and angle 7 form a linear pair. You don't know that. The only way that angle 5 and angle 7 would form a linear pair is if angle 7 was a right angle. It doesn't look like it's a right angle. You can say that it's not a right angle, but you're not 100% sure. So, I mean, that one's a little questionable, but what do we know about a linear pair? A linear pair is set up by adjacent angles. Is angle 7 adjacent to angle 5? No, it's not. So think about your definition, because I know you might be able to talk yourself into thinking that they could be or couldn't be, but remember that they're not adjacent, and that's the definition of a linear pair. They have to be adjacent angles. All right, last one, number 47, was about the wing of this plane. So you have this aircraft, and the wing pivots 60 degrees in either direction. So question 47, it says, is there a wing position in which none of the angles are obtuse? So the only wing position in which none of the angles are obtuse is the current wing position. Like if you left it in the setup that it was at. So that would work. However, if you try to rotate or pivot these wings in any way, anything between 90 and 180 becomes obtuse. Currently the wings are perpendicular, so that's good. But if you do any kind of movement where it's a pivot, the 90-degree angle may get smaller, but the other 90-degree will get larger. So this is how I want you to think about it. If this is the wing, and let's say that I want to move it like this, this angle now becomes greater than 90, which is obtuse. This angle becomes less than 90, which is acute. So the only setup is in their current situation. That's it. Okay? All right, that's your homework. If you have any questions, make sure you message me. I was totally disappointed that nobody joined in on the discussion for yesterday. So I'm assuming nobody had questions on their quiz, and I only got 2 requests for retakes. So you can go ahead and get started on your lesson.